Alright, so the instructions for the examples that we're going to be doing are for us to find the derivative of the following functions with respect to x using the definition of the derivative. Okay, so for question number 1, let's say we have the function y equals x plus 5. Alright, so in this particular example, we're going to be looking at a linear function, and we want to figure out how to differentiate, how to find the derivative of this linear binomial using the limits definition of derivatives. Okay, so to get us started, we are going to write down the formula that will guide our problem solving process. So the formula for the limit definition of a derivative is given by dy dx, the derivative of x with respect to y, is a limit as h approaches 0 of f of x plus h minus f of x, and that entire expression we're going to divide by h. Okay, there's another formula, another limit definition, but we're not going to use that in this presentation. We're just going to stick with this one for this example. Okay, all right, so what we have to do in this particular problem is we need to find two ingredients. We need to identify f of x and f of x plus h, plug it into this formula, simplify, evaluate the limit, and we should be done. Okay, all right, so let's start with the easy part, which is f of x. What is f of x in this problem? F of x is y. Okay, and y is what? Y is x plus 5. Okay, next, so we have the first ingredient down. Next, we need to find what f of x plus h is. So what is f of x plus h? If we have f of x, we can easily compute what f of x plus h is. All we're going to do is evaluate the function at x plus h. Basically substitute x plus h in all the spots that you have x in the function. Okay, so instead of x plus 5, we're going to have the quantity x plus h plus 5. Okay, let's go ahead and simplify that. So if we simplify that, we're going to have x plus h plus 5. That is f of x plus h. Okay, now we have everything that we need. Let's go ahead and compute what the derivative is. So dy dx, the derivative of y with respect to x, is the limit. We're now going to apply the two results we got, f of x and f of x plus h. We're going to apply it to this formula. Okay, so f of x plus h is x plus h plus 5 minus f of x. F of x is x plus 5, so it's a linear binomial. We're going to group it in a parenthesis, quantity x plus 5. And that entire expression we're going to divide by h. Okay, so if we found out f of x plus h and f of x, we have substituted. Now we're going to simplify and then evaluate the limit. Alrighty, so let's simplify this. This is going to give us the limit as h approaches 0 of x plus h plus 5. Distribute the negative across these two terms in this parenthesis, minus x minus 5. That will be divided by h. So let's simplify this as much as we can. Okay, so what goes on here? Positive x and negative x, that combines to 0. Positive 5 and negative 5, that combines to 0. So we're just left with h. Okay, so the derivative of y with respect to x is the limit as h approaches 0 of h over h. So we'll simplify this. When we simplify this, h divided by h is just 1. So this becomes the limit as h approaches 0 of 1. So there are no variables for us to substitute. What h is approaching into in this polynomial function is a constant. So regardless of what h does, the limit is always going to be 1. Okay, so our final answer is 1. So the derivative of y with respect to x is 1. Okay, so just a side point, something to keep in mind is that when you're dealing with a linear function, the derivative is always the slope of that function. How do you find the slope? You just use y equals mx plus b, right? So if we use y equals mx plus b in this particular function, m is going to be 1. So just by looking at it and using your knowledge of slope for from algebra 1 and 2, you can easily compute what the derivative of linear functions are, because for a straight line the slope is always constant, the derivative is always constant, and is always equal to the slope. Okay, so let's try an example where we have a scenario where the slope is not constant. Okay, the slope changes, the rate of change of the function at different points on x changes for various values of y. What are we talking about? Let's take a look at a quadratic binomial, 5x squared plus 1. Okay, so the shortcut that we just talked about for number 1 cannot be applied here. Okay, because we have a variable's slope, so our derivative is going to be it's not going to be a linear, it's not going to be a constant, there's going to be variables there. All right, so let's go ahead and find the derivative of the function in number 2, y equals 5x squared plus 1. So let's revisit what the formula is. Hopefully you remember what the formula is. You can just look at it right here. Let's just write it again. So the formula is dy dx, the derivative of y with respect to x, is the limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay, all right, so like we did for number 1, we're going to look for the ingredients to apply this formula to. We just need to determine what is f of x. We need to determine what is f of x plus h, substitute, simplify, evaluate the limits, and we'll be done. Okay, all right, so let's start with f of x. What on earth is f of x? In this particular example, f of x is the same thing as y, and y is 5x squared plus 1. Okay, so now that we know f of x, we can easily use that to determine what f of x plus h is, which is just the same function evaluated at x plus h. Or in other words, just substitute x plus h for all the x's in the original function. Okay, the original function is 5x squared plus 1, so I'm going to take out the x and replace it with parentheses. Now, why are we doing that? We're about to substitute x plus h into the position of x. Okay, so it's basically this function y, or f of x, composed with x plus h. So we're going to put x plus h here, substitute it for x. Now we're going to simplify this resulting function completely, and then we will be ready to carry out our substitution. Alrighty, so let's simplify, expand this. X plus h, quantity x plus h squared just means that we're going to multiply x plus h by itself twice. Okay, so you can FOIL that out, or you can use the shortcut, the formula for squaring binomials. That's what I'm going to use right now. So if you square that, you're going to have 5 times a squared plus 2ab plus b squared. Okay, plus 1. So the formula that I use is this formula right here. If you have quantity a plus b squared, you can just simply use the formula a squared plus 2ab plus b squared. All right, if you don't remember the formula, you can just FOIL it out. You end up with the same answer. The two terms in the middle will be xh's, and you combine them and you get 2xh. Okay, let's go ahead and continue with our simplification. Distribute 5 across all the terms in the parentheses. So we have 5x squared plus 10xh plus 5h squared plus 1. Okay, so this is as far as it goes. There aren't any like terms that we can combine, so we already know what f of x plus h is. So we have our two ingredients down, f of x and f of x plus h. We are now going to substitute them into their respective locations in the formula for the limit definition of the derivative. Okay, so the limit as h approaches 0 of f of x plus h, f of x plus h is 5x squared plus 10xh plus 5h squared plus 1 minus f of x, which is quantity 5x squared plus 1, and then we're going to divide that by h. Okay, so now we have the substitution step carried out. F of x plus h and f of x are substituted into the formula. We're now going to simplify this quotient of polynomial expressions completely, and then we will evaluate the limit. Okay, all right, so let's go ahead and simplify that. So we have a distribution action happening on the leftmost side. So we have 5x squared plus 10xh plus 5h squared plus 1. Then when you distribute this negative to these two terms on the right here, that's just going to alter the sign. It's just going to result in the opposite of these two terms. So they're now going to become minus 5x squared minus 5. And this entire numerator expression will be divided by h. Okay. All right, so let's see what we can reduce here. What can we reduce? Let's see. Oh, 5x squared, positive 5x squared, negative 5x squared, cancel out. What else? We have, oh, this right here is supposed to be minus 1, not minus 5. So minus 1. That would have been strange. Okay, because minus 1 divided, negative divided to positive 1 is just negative 1. Alright, so positive 1 and negative 1 take each other out. Those two are gone. No other cancellation action happening. Okay, so we'll bring down what we have. We're now going to have the limit as h approaches 0 of 10xh plus 5h squared divided by h. Okay, so in the numerator we can see that there's a common factor with these two terms, namely h, so we can pull that out. So the limit as h approaches 0, factor out that h term, and then we're left with 10x plus 5h divided by h. Oh, nice. We can now divide out that h in the denominator with this h that we just factored out. Those two divide out. And now we're left with a limit evaluation problem. So the derivative is now going to be the limit as h approaches 0 of 10x plus 5h. Okay, so remember our properties of limits. When we're dealing with a scenario like this, we can just use substitution. Substitute 0 for h, and then we have 10x plus 5 times 0, which is just 10x plus 0, and that's just 10x. All right, so ladies and gentlemen, the answer to question number 2, the derivative of the function dy dx the d dx of 5x squared plus 1 is 10x. Okay, all right.